Welcome back, my friends, to the mill that twists and bends. Yes, this thing's like a wet noodle, but I'm here to make the most of it. And right now I'm drilling part of the cradle for my dynamic balancer. And I got one hole already drilled, and I almost forgot to video this thing. So I'm going to drill the next one right here. This is 1/4 inch, and it's spaced 1/2 inch off the back and 1/2 inch off the top. So without further ado, it's time to drill. Well, first we'll mark a spot. And I'm double and triple checking. That's what I was doing on the last hole. I'm using a stop on this side. I don't know if you can see it or not. Let me move it down just a little more. That way, everything that I do is a 1/2 inch is based on this, and this is nice and tight. There are fancier things you could use, but hey, I'm cheap. So are a lot of you. And with that, I will bring this up. And I will use the magic tool changer. Okay, now we're going to drill that hole. 1/4 inch. Remember to peck at it so you don't get long streamers coming off of this. Pardon me while I rearrange this part and deburr it. It's a little hairy coming off the back side. So let me deburr this thing. Oh, always check the work. That's what I wanted. Now, we're going to take a 1/4 inch end mill. Okay, I'm going to set the Z on the DRO so I know how deep I'm going. I'm only taking this down 1/2 inch because that's the capacity of this end mill. So I'm at 0. Oops, wrong way. Let's turn on the power feed. And what I'm going to do is initially take this down to 1/2 inch. Then I'm going to take 3/1000ths off the back and 3/1000ths off the front to clean it up. Maybe 4/1000ths on each side top. So I'm trying to keep this narrow as I can before I go deeper. The other end mill I'm using is longer, and consequently not as rigid. It's a 1/4 inch all the way up, whereas this one's 3/8, and this one's stiff, and I like using this just to start the hole, but I can't finish the hole with it. That's the problem. This will go down to 7/8 to 1.75 inches, and the first inch has to go all the way to 1 inch, and this only gives me a 1/2 inch of cut. So see my dilemma, but it's the one I prefer to do that first 1/2 inch with. Make sure that, okay. And now because of this mill, I'm only taking 50 thousandths of a cut. Oops, wrong way. Cable cane would tell you when you try to plunge mill and go sideways this deep, it's rougher than the top, which is why you come back and you clean it up. Okay. We're at 1.723. Turn off that stepper motor, otherwise it's locked. Okay, coming up on 750, we're there. Switch the direction. Okay, and we will drop in another 50 thousandths. And I'm not going to bore you with taking this thing down to the full 1/2 inch. I'm going to get on ahead. Because this is all going to be vacuum cleaner and loud. After you see me make the pass twice, you kind of get the idea. So I'll let you take a nap until I get to the next point.
Eventually.
As you can see, I am currently at a depth of a 1/2 inch, which is the limit of that mill. Now I've taken 4 thousandths off the back and 4 thousandths off the front. And if you look, you can see that surface, oops, the surface is nice. It's not all rough. I did a 4 thousandths pass up and a 4 thousandths pass back, which took this to a 1/2 inch wider than, or a half. 8 thousandths wider than the cutter, which is just enough to give it clearance so you're not recutting your cuttings, and gives it a nice finish. Now, at the top I'm going to do a little bit less than that. I'm going to clear it just enough to get the little arms in there that I made. And while they're supposed to be a 1/4 inch, I find they're a little bit over. And since I'm not going to sit there and skim them, I'm just going to make these a little bit wider, because it's not a critical dimension. They're riding on bearings. So with that, I'm going to use the magic tool. So now I'm going to set the 0 on here. I'm going to raise it up 500. And I'm going to set 0 so I know my depth. My depth of cut. Now I'm going to take this down to 7/8, all but the last inch. So I'm going to start at this end. On this side here, I'm going to take it all the way down through, and I'm going to do that for 1 inch, because these are 1 inch wide, and I want to make sure that I clear on the curve as it comes around. So let me bring this over, position it, and I'm going to get out the vacuum cleaner, and for the first 1 inch on the DRO, I'm going to cut this thing all the way down through. And there's nothing really to be seen here. It's just something that I'm done, that I know you all seen, and I really don't want to sit there and listen to the buzz of a vacuum cleaner for about the next 20-30 minutes. So I'm going to plunge this down. I do it about every 25 thousandths, and that keeps the debris clear, makes for a nice cut. I've already cut one of these, and that was just checking for clearance. And this is just nothing more than a copy of the first one. But when the DRO hits 1 inch, then I shift it up to 7/8, and finish the rest of the cut out to 0.175. Actually 1.750. I will see you in a bit. You go take a nap so you don't have to listen to all this.
A few moments later.
Changed my mind just for a little bit of this. I'll let you see the start. And I go one little bit, I chew it out a little and move on. Right now I'm close to the end. It's throwing everything out the back. As soon as I pass through, I come all the way back up. And another 25, take a bite. I'm trying to do this without flexing the end mill. This is solid carbide, and I do not want to break it. They're taking off too much of a bite. They don't bend. And this is a pricey little number for these end mills go for me, because I don't often buy solid carbide. Okay, that's 60 thousandths to the other side. So I'll be doing this until the DRO hits the 1 inch mark. I shall see you in a few. Okay, I got my stop set to 0.875, and I'm going to take it out to 1.750 the rest of the way, getting clearance at 4 thousandths front and back, and this side will be done. Just gone forward a little bit, and it's going to be me and the vacuum cleaner again, so I'm going to let you guys sit that one out, and I'll bring it back when I get it nice and quiet.
A few moments later.
Okay, I got it all cut. Gave a little clearance fore and aft. Let's see how I did. Pretty fair. I think it made the grade. I think we can use it. And I'll do the other side. Since that's a rinse and repeat, you don't necessarily need to see that. I think I can manage. Let me get everything spread back apart. Get it locked in here for the second round. And I'll see you at the end of this and show you the other end.
1 minute, 37 seconds later.
This is the part we just made, and it's a finished piece. I've given it a little bit of satin shine with a little bit of Scotch-Brite. I think it will serve me well. I've already made some other parts. There's 2 of these, and they get pinned in like this. And what happens is it rocks like a cradle, but always maintains this parallel with the ground, and that sits on this. Actually, this is next operation is to screw this to the bottom of that, and that will fit like that. In fact, these here give this a little clearance, and they're so tight when I initially set them up that they will hold the 1/4-inch pieces while I align them to be machined for 6 5mm screws coming back the other way. And like I say, they'll be suspended by these from a long bar above it like that. And this bar gets these except longer the other way because it's going to be able to rock in both directions. And this whole thing has the second piece above it that's on 4 pieces of 5/8 round stock holding this up, which holds the bearing carrier and the shaft that powers the piece to be balanced. So it's not all that hard to build, but there's a lot of little pieces to it. So this is the project, and so far I'm pleased with everything as it's turned out. These are press fit and they're nice. And this is the video that made these is going to be the next one up. And included in that is the use of this tool that I made to radius the end of the parts. I have it on a rotary table in a 4-inch chuck. You can see where these were made. Oops. And I disengaged the worm gear on the rotary table. So instead of having to sit there and wind that little hand crank all day, I just kind of ran it like a router and just rotated the part under the cutter. I used a 1/4-inch cutter, and as you can see, the tool is the perfect fit. This is the tool that they were made on, and I wish this was a little bit bigger in diameter, but this was all I had on hand, and I'd had rather used a 3 or 4-inch piece. But I'm out in the middle of nowhere, and it would have taken me a week to 2 weeks to get a piece over here. Everything that I get, everything that you've seen, is mail order. I live in the Oklahoma nowhere. I am 40 miles from the nearest interstate, in a town of 6,000. So, and even my hardware store, the smallest thing they carry is $1/4 20. Metric screws I have to order in from Florida. But the one thing I like about it out here is it's quiet. I'm retired and I can work in peace. And that's it for this video. Like, share, and subscribe if you like what you see. If not, well, the heck with you. I shall have the video of these being made probably within the next week. It's already done. I'm just going to let this one sit in and get its views and bring out the next. And then I'll bring out these and the pairing of these to this. And the hard part is going to be fitting these into this and these. So I'm going to cut these so that they're the width of the axis center of the U-bolt, and that half of the bearing is into the aluminum, the other half is supported with the U-bolt, and that's going to leave me a 1/4 inch under when I get it all done. And this sits on top of the top flat piece, and that pretty much makes up the one end. The other end's got a pivot on it, and powering this thing is a sewing machine motor. The pickup to time the readout on the trigger for the oscilloscope is an infrared optical sensor, and a 4-inch laser cut stainless steel disc, which I will paint black except for one silver stripe across it so it can be read as the photocell runs around. The weight is going to be measured on an accelerometer, and it'll just appear as on a dual trace scope as the waveform from the accelerometer and the trigger, so it's triggered at the same point by the optical sensor. It's this setup here is a combination of two homemade balancers that I've seen. One ran software, which I don't feel like spending the $2,000 for, when a $250 scope will bring me in just as good. And with that, I will close this video and bid you adieu until next time. Thank you.